Hello my dear students and welcome to this lecture series by AKtU. I am Dr. Supriya Praladpam, Assistant Professor in BBD ITM, and I will be taking a Unit 3 of Environmental Engineering, which has subject code KCE 603. This is my sixth lecture, and as you already know, we have already completed 5 lectures. In the last 5 lectures, we have talked about the physical and the chemical and the bacteriological examination of water, and we have talked about the standards for water. In after that, we have talked about the physical and the chemical. We are still talking about the chemical examination of wastewater right now. So, right now our focus is on wastewater. So, continuing with that, in the last lecture I have completed solids. After that, let us come to the next slide, which is pH. We have already talked a lot about pH in water. So, let me just very briefly tell you 2-3 points for pH value for wastewater. pH value, as we have already talked about, indicates the log of reciprocal of hydrogen ion concentration. It is already, we already know this, that pH is equal to minus log base 10 hydrogen ion concentration. Actually, pH is very important for wastewater. Why is it very important for wastewater? Because when we talked about wastewater, we are going to talk about treatment of wastewater, right? And lots of that treatment is dependent on the pH value of the wastewater. Say for example, actually here I am talking about a physical treatment types, are not the physical treatment type, I am talking about the chemical treatment type. For physical like sedimentation, we won't be pH is not an issue, but when we talked about chemical treatments that time, or when we talked about biological treatment, that time pH will play a very important role, right. Because if it is too acidic, those bacteria will not be able to survive, or if some chemical reactions will not be possible at a particular pH. So, determination of pH value of wastewater is important because of the fact that efficiency of certain treatment methods depend upon the availability of suitable pH values. Now, let us come to the chloride content. We call chloride content for water, we have already talked about. Let us talk a small bit about the chloride content for wastewater or sewage. Chlorides are generally found present in municipal sewage and are derived from kitchens. We use chloride in the form of sodium chloride, right, human feces, urinary discharges. Large amount of chlorides may enter from industries like ice cream plants, right, meat salting, and thus increasing the chloride content of sewage. Chloride content of water can be measured by titrating the wastewater with standard silver nitrate solution using potassium chromate as indicator. So, chloride here, this is chloride. Now, let us come to nitrogen content. We have talked in depth about nitrogen content in water. So, we have already talked about blue baby disease, we have talked about how about the types of nitrogen content in water and wastewater here. So, I will be briefly telling you a little bit more on nitrogen content. So, actually if waste nitrogen is present, or presence of nitrogen in sewage is an indicator of the presence of organic matter. If nitrogen is present in any form, okay, it means that some type of organic matter is present in that sewage and may occur in one of the more following forms. We have already talked about here, right, free ammonia or ammonia nitrogen, albuminide or organic nitrogen, nitrites and nitrates. We have talked about this. This is similar to the water part. So, here, okay. So, let us move to the next topic. This next slide is completely different from and it is not present in water. So, already I have told you that there are some characteristics which are common for both water and wastewater. Say for example, as we already saw, pH can be measured for both water and wastewater, chlorides can be measured both for water and wastewater, sulfates can be measured, right. But this fats, grease and oils, you do not expect that in water. you expect it only in case of wastewater. So, this will be is completely for wastewater. So, let us talk about here presence of fat, grease and oil. They are derived from the discharges of animal and vegetable matter from industries like garages, kitchens of hotels, restaurants, plus your domestic kitchens, right. Obviously, the amount is going to be lesser, but then they have a good contribution, right. Then what will they do? So, what are they? They are fat, grease and oil. So, they are properly oiled. So, what do? They will obviously going to float on top of the water. So, when if you put oil on say if you have a glass of water and you put oil, what will happen? That oil is going to float on top of the water, right. Similar thing is going to happen here. What is going to happen? When this this oil and grease and fats, they are going to get mixed up with the wastewater, they are going to come up and they are going to settle on top of the wastewater. So, they are going, what they are going to do? They may form scum on top of this sedimentation tank. What will happen? Because obviously, it is lighter, they are going to form a layer here. Okay. And clog the filtering media, hence may interfere with the normal treatment methods. So, what are they going to do? Say for example, if I am going to if I am going to use say if I am going to use trickling filter, say for example, for wastewater treatment. So, what are you going to do? Since this oil and grease they are there, what will they do? They will be present, they will make themselves available at the top of the wastewater and finally on top of the filtering media, and then they will choke up the filtering media. Not only that, what will happen? They will block oxygen which is going to be coming from the atmosphere and will not allow it. So, anaerobic conditions may start forming in this cases, right. So, we have to, to avoid certain this types of problem, what we have to do? We have to remove this scum before we go for further treatment. So, because of for this what we do in when we go for sewage treatment plant, when we go for wastewater treatment plants. So, what we do? We have a certain tank which is designed to remove all this fat, grease and oil, and that is called skimming tank. Right. So, what will you do after in the say if in the preliminary treatment or the primary treatment, some people call it some people club it with preliminary, some people club it with primary, does not matter, but then the skimming tank is used to remove this fat, grease and oil. Okay. So, so, it can be determined. How is this fat, grease and oil determined? It can be determined by evaporating the sewage sample and mixing the residual solids with ether, and then evaporating the ether and leaving and the fats and the grease as residue. So, first they are going to evaporate the water, means you are going to remove the water, and whatever will be left is going to be mixed with ether. And why ether? Because it is organic and organic solids will dissolve in organic, right. Since fat, oil and grease will be organic, right, and then evaporate the ether, leaving the fat, grease and fats and grease as residue. So, fat, grease and residue are actually a very important part of wastewater treatment system, because without this even though if you have planned your wastewater treatment plant, if you planned your sewage treatment plant very nicely, then also if you do not if in certain area, if people have this habit of certain more using more oil, more grease and all in that places, skimming tanks are actually very important. Actually, they are very important, has to be included, right. So, now let us come to the next topic, that is sulfides, sulfates and H2S gases, that is hydrogen sulfide gases. We have already talked a little bit on this about in water. Now, for wastewater, sulfides, sulfates are formed due to decomposition of various sulfur containing substances present in sewage, which leads to evaporation of H2S gases, causing bad smells and odors, besides causing corrosion of concrete sewer pipes. Right. So, obviously, when we talk about sulfides and sulfate, you expect that they will be coming from sulfur, right. So, when there are two types of decompositions here, or two types of reactions. One is going to be the aerobic, another is going to be anaerobic. So, aerobic in the sense in the presence of oxygen, here in the absence of oxygen. Right. So, when you have aerobic decomposition, sulfur and its compounds, that is sulfides, they are going to get converted into sulfate, right. Here, so you means aerobic in the presence of oxygen. So, you have oxygen here, you have already put oxygen here, whereas in case of anaerobic decomposition, you are doing that in the absence of oxygen. So, what will happen? This sulfur and its compounds are going to get transformed into sulfide, H2S gases, methane and carbon dioxide. Okay. Now, let us come to the next topic, which is actually very important. We are going to talk about dissolved oxygen. Dissolved oxygen, after dissolved oxygen, we will be talking a little bit more on on COD, which is the chemical oxygen demand, and BOD or biochemical oxygen demands, which is actually the core of wastewater treatment. So, these two things without understanding what is dissolved oxygen, you cannot understand what is COD and you cannot understand what is BOD, right. So, let us talk about it. Dissolved oxygen is the amount of oxygen in the dissolved state in wastewater. So, what is dissolved oxygen? The most important thing you have to understand, it is nothing, this is actual oxygen is actually oxygen itself, but it is in dissolved state, means it is in water, be it water or be it wastewater. Wastewater is actually water only, just have this pollutants, right. But then the dissolved oxygen in the sense that water which is already in water, oxygen which is in water, not in the atmosphere, right. And how will you get that? You will get this dissolved oxygen by transfusion or by diffusion of oxygen from atmosphere. This is atmosphere and this is water. Okay. So, by diffusion, there are certain other ways also, diffusion by aquatic plants, right, many thing else. You should go and check it out. Okay. Though the wastewater generally does not have DO, its presence in untreated wastewater indicates that wastewater is fresh. Actually, what is happening is that in dissolved oxygen is actually in water, you will have dissolved oxygen, because it is like it is already there. But when we talked about wastewater, when it was fresh, there will be dissolved oxygen, but what will happen with the passage of time, those oxygens will be used up to oxidize the organic matter present, and after certain time those all oxygens will be used up, right. So, that is the reason why you do not expect any DO in wastewater, right. But certain, if say for example, wastewater it is fresh, then you expect certain DOs. Similarly, its presence in treated wastewater effluents indicates that considerable oxidation has been accomplished during the treatment stages. Say for example, what you are doing, when say for example, you have certain when you treat wastewater, what will happen, they will go through certain stages, you will have aerobic treatment or maybe anything, right. But what will be coming out of the wastewater, what will be coming out of the wastewater treatment plant, the effluent, before you discharge it into the before you discharge it in a river or any sea, or if you anything, right, they should have a certain level of dissolved oxygen. Okay. If not, then it is going to create lots of problem. right. So, dissolved oxygen. Why is it very important to have dissolved oxygen? While discharging the treated wastewater into receiving water, it is essential to ensure that at least 4 milligram per liter of DO is present in it. If DO is less, the aquatic animals like fishes etc., are likely to be killed near the vicinity of a disposal, right. Fishes they or aquatic plants they also require oxygen, right. So, what will happen if this is less than 4 milligram per liter, the fishes will started dying off. It is like you are being deprived your essential oxygen, right. You suffocate literally. So, it is very important. So, what will happen? So, you when you discharge, say for example, you have an industry here and this is discharging their effluent in a river. Okay. Say for example, this is discharging here. So, the effluent you discharge here should have at least 4 milligram per liter of DO or dissolved oxygen, right. If not, you will have fish kills here in this vicinity, right. Now, next here we will come to the next thing slide. Dissolved, say again we are talking about dissolved oxygen. A DO test should be performed on sewage before the treatment to indicate the condition of the sewage. So, DO test should be done on a sewage, and how do you do the DO test, that also we will be talking about. Presence of DO in wastewater is desirable because it prevents formation of obnoxious smell. अगर ऑक्सीजन नहीं होगा then what will happen, it will start giving very bad smell because of oxidation, because of this hydrogen sulfide presence and all. Okay. DO determination should also helps to determine the efficiency of biological treatment. So, this DO is actually very important because when you measure BOD and all, this is all done through DO only. So, you what is actually BOD? You will measure DO at a particular stage and then see how much is being consumed, right. So, DO is generally determined by Winkler's method. This is very important, which is an oxidation reduction process in which iodine is liberated in amounts equivalent to the quantity of dissolved oxygen originally present, right. So, Winkler method, which is very important, right. So, here now let us come to the next slide, which is the core of environmental engineering, very important topic, biochemical oxygen demand or BOD. Most important, if you understand, like whatever exams you give, everyone will ask BOD, okay, that is for sure. So, what actually is BOD? It is very important we understand that, and very important for wastewater. So, there are two types of organic matter present in wastewater. There are two types. One is the biodegradable or biologically active and non-biodegradable or biologically inactive, right. So, what are this? Biologically means this can be degraded by biologically active, this can be biodegradable. Okay. So, this can be degraded by microorganisms or bacteria essentially. Here this cannot be degraded by bacteria, they will be you will require strong oxidizing chemicals to degrade it. Okay. So, what you have to remember here for BOD? What you have to remember here for BOD? You have to remember biodegradable and non-biodegradable. Okay. So, what is biochemical oxygen demand or BOD? Organic matter. So, what is going to happen? This organic matter is going to be oxidized. Okay. Now, this oxidize, it can be through two times. One can be biologically, another can be chemically, right. Biologically in the sense through microorganisms, and chemically in the sense by using strong oxidizing chemicals like potassium chromate and right. So, which can be done biologically, okay, which can be, you do not require a lab to do it, that or the oxidation is going to give you BOD. So, what is BOD? The organic matter is often assessed in terms of oxygen required to completely oxidize the organic matter to carbon dioxide, water and other end products of oxidation. So, what is BOD? Biochemical oxygen demand or BOD is defined as the amount of oxygen required by microorganisms, mostly bacteria, to carry out decomposition of biodegradable organic matter under aerobic conditions, right. So, you are going to use up this bacteria, you are going to use up this bacteria in an aerobic conditions. So, they are going to be either aerobic bacteria or facultative bacteria working aerobically, which are going to decompose this organic matter. Okay. So, that is called biochemical oxygen demand, right. Thus, BOD analysis does not oxidize all the organic matter present in the waste, only the biologically active organic matter. So, when you talked about BOD, we are not talking about oxidizing the whole organic matter, we are only talking about oxidizing whichever is biodegradable, which is biologically active, which can be degraded by the bacteria. So, what can be done naturally? So, my way of saying is that BOD is that amount of oxygen or that which can be which is required by bacteria or which can be required by microorganisms to decompose biodegradable organic matter naturally, which is actually possible. Whereas, COD or the chemical oxygen demand is that type of where you actually have to do it chemically, like you require some chemical which is actually not possible in a treatment plant. So, in a treatment plant we will be only using BOD, okay, we will be talking about BOD only, we won't talk about COD, because when you talked about COD, because BOD is possible, COD you cannot oxidize all the organic matter for a say for example, for a town in the lab, right. So, it is only for studies, like you will have an idea about what type of waste it is. So, thank you, and with this slide, in my next slide I will be continuing with the BOD and we will be talking about COD also. This is actually a very important part of environmental engineering, in fact the core of environmental engineering. Thank you so much.